Health and good spirits. It is my great pleasure to welcome you today. This webinar is part of the AI for Good Global Summit, which works to identify practical applications of AI to accelerate progress in sustainable development goals. We're in search of applications capable of achieving global impact. The summit is now all year online. The AI for Good movement continues to grow stronger, becoming even more inclusive and more scalable towards global impact. Let me highlight how today's webinar aligns with the strategic priorities of ITU. ITU is the United Nations Specialized Agency for Information and Communication Technologies. We are a global membership of 193 member states and over 900 companies, universities, and international and regional organizations. International standardization is a key part of ITU's value proposition. We are unique in the ICT standardization world as the only body with a membership including governments. And we're also unique in the UN system as the only body with a membership including the private sector. As we take global action to protect our environment, we can reinforce this action by working together in international standardization. Today's webinar is organized by the ITU Focus Group studying AI and environmental efficiency. Participation in our focus group is open to all, and you are all most welcome to join the focus group meeting beginning tomorrow. Today, we will discuss AI and sustainable transformation in the context of energy, mobility, and smart cities. We will discuss how different industries are working together to take full advantage of digital transformation. And we will discuss how ITU standards can help to create global access to the latest innovations advancing environmental efficiency. Our discussions today will feed into the focus group meeting to follow. This meeting also aims to finalize the focus group's first 6 reports for the considerations of its parent group, ITUT Study Group 5. ITUT Study Group 5 is a well-established authority on ICT's relationship with our environment. With this focus group, Study Group 5 is inviting new voices to influence its efforts on emerging technologies to bring new dimensions to this work. I would like to thank my friend Paolo Gemma and Neil Sahota, the co-chairs of our focus group, for their leadership of this group as well as their work arranging today's webinar. We have an excellent program ahead of us, and I would like to thank all of our speakers, moderators, and participants for your participation. We highly appreciate your support. We aim to create an interactive, engaging discussion, and I encourage you to make use of the Q&A function found at the bottom of your screen, as well as the chat function that you can use to either chat with everyone or the panelists. It is now my pleasure to give the floor to Paolo Gemma, who serves as the chairman, co-chairman of the focus group, but also chair of the ITUT Study Group 5 Working Party 2 on environment, energy efficiency, and circular economy. Thank you very much. Paolo, the floor is yours. Over to you, Paolo.
I see always you. I hope that is working now. Okay. Hi to anyone. Thank you, Bilal, for your nice word. I hope that you are able to hear me.
Yes, loud and clear.
Okay, thank you. And welcome to our webinar organized by the Focus Group on Environmental Efficiency for artificial intelligence and other emerging technology. This is the third workshop that we made on this work group. We made the first in Vienna last year, 2019, sorry. We are in 2021 now. Likely it was a physical meeting, a physical workshop on the snow of Vienna. Very nice workshop and a nice location. And we repeat another webinary last year in December. Now we have number 3 dedicated to two topics very dealing with energy, transport, and smart energy. Our focus group is working on deliverable dealing with artificial intelligence application for environmental efficiency, and also to check which is the effect of artificial intelligence and other environmental and other emerging technology on the environment. So we will look on both face, the benefit and the malefit of this new technology. The focus group, as said by Bilal before me, is open to anyone, and we have a good participation till now. We are working well. We are just finalizing the first 6 deliverables that will be approved tomorrow, and I invite all of you, if you want to join our focus group meeting tomorrow at 4 o'clock always. I don't want to take too much time, and I invite you, and I hope that to follow our webinar, and I hope that you find it very interesting, our webinar, and please send us all the questions that you want. We will try to answer to you directly or maybe later in the next days. Give us the time to answer to all your questions. And thank you very much for your participation. And now I will give the floor to the other co-chair of the focus group, Neil Saota. Up to you, Neil.
Thanks, Paulo. Welcome, everybody. Thanks for joining us. We're going to kick off with our first group of speakers. So we're going to focus on AI and energy. We'll focus on SDG number 7, affordable and clean energy. So we've got 3 fantastic panelists. Each is going to give a brief, about 8-minute talk to kind of tee up some key issues. And then we're going to actually jump into a panel session. So as you're listening to our fantastic speakers, if you have any questions, please use the Q&A box within Zoom to ask, and we will try and incorporate as many as we can during the panel discussion. With that, I'd like to kick it off with our first speaker, Dan Jevins, who's the General Manager of Data Science at the Shell Corporation. Dan?
Fantastic. Well, thank you so much for having me. I'm hoping that this is working and that you can see my screen. Maybe if you can just confirm that for me.
Yeah, I think we're good.
Super. Excellent. Good. Well, thank you. As was mentioned, I'm absolutely delighted to be here. And what I wanted to talk to you about today briefly is what we're doing at Shell to try to use AI to transform the energy system. I thought I would start by saying that we are very much in the midst of 2 changes in the energy system. The first is, of course, energy transition. We recognize that there is a huge challenge ahead of us to transition our entire energy system to lower carbon sources of energy. We want to play our part in that, and we are very keen to accelerate that journey as we've laid out in our recent strategy to be net zero by 2050 or sooner. And that includes our scope 3 emissions. And I think as part of that commitment, we see digital technology and AI playing a key part, which leads me on to my second theme, which is digital is also transforming the energy industry, both our traditional energy assets and also is becoming increasingly core to the future energy system. And at Shell, we see AI as playing an absolutely crucial part in that. And we see that AI has the potential to be one of the key levers, in our opinion, to accelerate energy transition. And I'll try to explain why I see that as such a key lever during the course of this short presentation. I think the key aspect of that is the fact that it can make our existing assets more effective and efficient, but also help us in developing new business models, both in terms of cleaner technology and also for our customers. But maybe before I do, just to give you an idea of the scale of our program and what we're trying to do, within Shell, we announced our strategy day really that we've seen significant value already and significant scale already being achieved from our AI deployment. To give you just some statistics, we're aggregating trillions of rows of data across all of our asset base to give us real-time data feeds around every asset that we operate. We've got about 350 data scientists and AI engineers who are now part of a core discipline trying to apply AI right across our organization. And beyond that, we have about 800 citizen data scientists. We're also using AI behind programs like our loyalty program, Go Plus in the UK. We deployed about 64 AI-powered applications to production last year. We're monitoring over 5,000 pieces of equipment using AI, and the list goes on. And I think perhaps the key metric is we're seeing significant value from AI across our organization in terms of lower costs, improved production, improved utilization of our assets, and increased margins. But I think perhaps even more important to me is the fact that all of this scale in our AI deployment is also starting to have a material CO2 impact. So I wanted to touch on three core themes today: the impact that I believe AI is going to have on our existing assets, trying to make them more effective and efficient, reducing the CO2 impact where we are unable to decarbonize the value chain immediately. I think the second part is going to be where we see AI playing a key part in the development of new cleaner technologies, which are accelerating energy transition. And finally, how partnerships with our customers is also helping on this journey. So let me just talk briefly about CO2 in our existing businesses. Within Shell, we have a number of technologies which we're rolling out across our core asset base. This is things like LNG plants and manufacturing plants and upstream facilities and the like. And what we're trying to do here is to use things like carbon abatement monitoring to look at impactful investment decisions that we can make to reduce the CO2 across our entire portfolio, to prioritize effectively, and to inform the CO2 target setting process. So we're using AI and digital technology to drive that across the global asset base. We're also using it, though, to develop optimization algorithms, which have...
Hey, Dan, sorry to interrupt. We actually we're not seeing your slides anymore.
Okay.
Are you still sharing your screen?
I am. Did you lose it, or?
I saw it at the beginning, but it's for some reason dropped.
Okay, I will go back and I'll reshare. Thank you for telling me. Can you see the screen again now?
No. Sorry, everyone, just give us a moment here. When you click share screen, what's happening?
I'm getting an error. I'm fine. I can continue without the slides. It's okay.
Okay.
No
Okay. Thank you. Sorry, everyone.
No worries. So as I was saying, I think the second example that we wanted to talk through is around the optimization technology. We developed real-time production optimization technology, which allows us to both optimize the way in which we produce things like LNG, but also to reduce the CO2 impact of that. So we've seen huge, very significant impacts from that in terms of the overall CO2 footprint of the process. And as we have said publicly, obviously gas is a key transition fuel as a lower carbon form of power generation, for example. And also we're rolling out technologies like digital twin, which are helping us find new areas to make processes more effective and efficient. So that's in our core business, but of course we're also moving into the next generation of clean technology. And as many of you will have seen, probably we are accelerating the development of an electric vehicle charging network. We have about 165,000 chargers now worldwide, and that's growing very dramatically. And we expect that to continue over the coming period. And we're very excited by the potential of that to transform the transport sector. But also, we recognize the role that AI can play in helping to accelerate all of that in terms of optimizing things like the charging processes. So we recognize, for example, that if everyone plugs in at the same time on the grid, that can put a strain on the grid, but also doesn't maximize the use of renewables. And so we've developed optimization technology, which can help move the load on the grid and therefore maximize the use of renewables to reduce the CO2 footprint of the charging process. We're also using AI in things like carbon capture, utilization, and storage, where we're developing monitoring technology to ensure that the CO2 that we put in the ground stays in the ground, and that we monitor the events associated with that as we develop that technology as part of a new core business model. And of course, things like the Northern Lights program, which we've committed to recently, we expect to further accelerate the deployment of carbon capture, utilization, and storage together with our partners, Equinor, Total, and of course the Norwegian government. And talking of partnerships, and this is where I'll finish, we also see that a lot of this is going to be, a lot of the process of decarbonizing the energy system is going to be around working together with our customers. More than 90% of Shell's emissions actually come from the energy product, from the use of the energy products that we sell. And so making sure that our customers are able to decarbonize their processes is going to be key to us hitting our goals that I mentioned earlier on in the presentation. And so what we've been doing is trying to work customer backwards to partner with companies to develop solutions to solve their energy needs, but also to accelerate our own transformation. And a great example of that is the work we've been doing recently with Microsoft, where we've partnered with them both to provide them with renewable power at scale for their data centers, as well as also lubricants to assist in the cooling processes of those data centers and reduce the CO2 footprint there too, as well as also partnering with them to develop innovative digital products through the use of their cloud to further accelerate our digital transformation. So that's what I wanted to share with you. I think I'm just about within time, and I will hand back to you, Neil.
Thanks, Dan. That was perfect. Very well done. Hopefully, again, if you have any questions, please use the Q&A box for the panel discussion we're having. But we're going to, shift a little bit here because energy doesn't live in a vacuum. We need the industry innovation infrastructure, SDG number 9. So we're also going to talk a little bit about AI mobility with this. And our next speaker, John Steele, is the head of sustainability at Arrival. He's going to kind of kick off this conversation for us. So John, take it away.
Hey Neil, and hello everyone that's attending. Yeah, great to be here, and I have to say I'm fighting back the imposter syndrome here. I personally don't know all that much about artificial intelligence, so I'm going to talk more about the potential use here for environmental and sustainability objectives. So if I quickly find my slides, hopefully it will work. Fingers crossed, eh? Okay. Can we have a nod? Can anyone see anything?
We can see it.
Hey, great. Okay. Good. Okay, so I wanted to start off quickly by introducing Arrival. I'm aware that not everybody will be, aware of us. We are a startup in the technology and transportation space. And kind of it's useful, I think, to think about the kind of creation story for the company. So from a kind of technology point of view, the company was really set up because when we looked at transportation and vehicles in cities, we kind of realized that those products and the kind of hardware there and the kind of offering hadn't really been using the best technology that was available at that time. And this is for a number of different factors. Some of these products have many years of a development cycle. So we all know that digital technologies, AI and such, are developing at such a rate that if you used technology from 5 years ago, it would be quite outdated. You're limiting the kind of potential there. So really one of our objectives is to bring the best technology that we know about and that we have access to into use as quickly as possible and as kind of relevant as possible to now, to kind of use it to its full potential. So we, started off on that journey and tried to figure out how to do that. We really found that we needed to change or to create a new system of making these products and designing them and also using them. So here, I've laid out some of the kind of technologies that we have, some of the things that we think are really key to achieving this. I'll work from left to right really quickly. We have a very modular architecture of these vehicles. The powertrain components and many other parts are actually really plug and play. You take a module and you can install it really quickly. Yeah, it has its own kind of firmware. It can communicate with everything else. Everything works together really nicely. We're using these composite materials that are proprietary. We've developed the process and the material here to reduce the weight of the vehicle and also to allow one of the points to the right here, the microfactory. Now we produce vehicles in much smaller factories than you might be used to seeing for vehicles, and we're talking about 10,000 vehicles per year in a relatively low footprint building, and quite often that's an existing building. I'll come back to that point. So alongside all of this, we have a lot of our own software. We have a very strong software capability in the company, and we're developing systems for our own use, for developing and designing and that kind of actually the manufacturing processes as well, while we're also developing software for the user of the vehicle, the fleet operator, the bus operator, or even passengers or individuals that interact with these vehicles. So kind of through all of this, we have tried to create what we call a kind of digital ecosystem. And kind of effectively, the message that I'm trying to convey here is we need to be prepared. So if we're prepared for the technology that comes along in 1, 2, 5, 10, however long many years time, then we won't get left behind effectively. So we won't see this scenario where we have products and systems that are out there that aren't really using today's technology. We want to be able to harness the best and most up-to-date technology. So we design things to be upgradable. We design software to be vehicles to be connected and able to be updated over the air. So everything that we're doing here is to kind of increase that flexibility and to keep things up to date. So when we're talking about being prepared here, it's about actually recognizing that we'll have all of these different sources of data, and that's a huge asset. We need to be able to harness that and use it and understand how to then deploy AI to make use of that and actually to give insight. So the kinds of insights that we want to use here, I've kind of listed out some of these. So in the design and manufacture of vehicles, we're interested in actually how can we design not just a really great vehicle that everybody loves. It's about also designing something that's really fit for purpose. It doesn't have extra capability that you don't need. It doesn't also have not enough capability. It just has the right amount. So this concept we often call sufficiency. And a good example that I can give is if we're, range is a really popular topic for electric vehicles. If we want to, create a bus for a certain route, it's normally very well known what distance that bus is going to have to travel. So we only put in the capacity that's needed for that particular use. And that means that you're saving on the kind of upfront cost. You're saving on that environmental impact of making all of those things. And you're also saving on that weight that you're carrying around. So you don't really want that extra weight that's not actually delivering much of a performance benefit, since you never get into that range. So in order to do that, we really have to have a very deep understanding of that use case. And this is where that feedback loop is needed. So in the vehicle use, we want to be able to have the energy usage and performance of the vehicle being constantly monitored. And what that can then enable is for us to gain a really good understanding of how the energy usage relates to let's say, the topography and the actual use of that vehicle. So, maybe you put a bus into San Francisco and it's really hilly. You're going to need more energy, but exactly how much? The vehicle test cycles and drive cycles will give you an insight, but real world data is much more valuable in that respect. So, another part here would be the maintenance and upgrade and dismantling. And this kind of comes into circular economy a little bit too, because when we look at a vehicle, we look at it as a group of useful functional components, each of which has its own value and has its own lifetime. If, for example, a vehicle is damaged or comes to the end of its useful life for whatever reason, there's probably a load of components and a load of modules on there which we could keep using in another application, whether that's to repair an existing vehicle, to be remanufactured and brought back into use at a higher level of value, or actually just to reuse in a completely different application. So an important factor there is actually to understand, what is the condition of this thing? And there are concepts there like the kind of digital twin, where we can use AI to really understand the life that component has had and the environment that it's been subjected to. So all of this in terms of data capture is completely possible, and it's just a fact of stitching these together. So overall, then, really, we want to be able to use all of these amazing, rich sources of data to extend the vehicle life. We want to maximize the utility of these vehicles. We want to, have every kind of useful aspect maximized. Informing that design is really, really critical for us as well. So if we can tweak something, if we can change like an individual component and make a weight saving or reduce the environmental impact of making these things, then that's a massive positive. And the use of capturing these data and then using AI to actually understand and influence the design and the use is an incredibly powerful tool that we're utilizing. So I'll pass back to Neil and look forward to continuing the discussion.
Great, thank you, John. Appreciate that. I think carrying this concept forward and talking about how we can leverage, things like satellite data stuff. I'm proud to announce our third speaker, Sandrine Daniel. So Sandrine, are you ready to take it away?
Yeah, hello everyone. I'm trying to share everything. Do you see my screen?
Yep, I do now.
Great. So hello everyone. My name is Sandrine Daniel from Capgemini, and I'm part of the AI and analytics offer, and I am the lead of a team of experts in Earth observation. Capgemini's ambition is to offer solutions using AI while achieving carbon neutrality and aiming for net zero in 2030. AI and data have a determining role to better understand our environment, to understand the CO2 production of industries. So, because beyond the direct impact on humans and human society, other begins and the environment can be positively affected by AI solutions. The challenge is not only to guide human-friendly AI, but also to ensure Earth-friendly AI. The scale of the economic and health consequences of the deterioration of environment increases. So that's the urgency to act. We have an opportunity to consider how AI can help transform traditional sectors and systems to address climate change, ensure food and water safety, build sustainable cities, and protect biodiversity and human well-being. So we believe that AI systems should benefit all human beings. This means that their design and development must consider social and societal impact. Design and development must also consider future generations, the environment, and all being human and non-human that make up our ecosystem. So they must be considered as stakeholders throughout the life cycle of the AI solution to ensure that it's sustainable and environmentally friendly. So at Capgemini, we have consolidated a net zero framework to address challenges in societal areas as diverse as climate change and CO2 reduction, digital literacy and inclusion, environmental protection, improved health and sustainable food production. So with my team, we work with satellite data in order to extract important information for our environment thanks to AI. Today, there are many satellites orbiting our planet. With my team, we work with this satellite data dedicated to Earth observation. So we imagine and develop many use cases, and we can monitor air quality in our cities, monitor agriculture fields and forests. And with climate change, we also can also prevent extreme events such as floods. So today, I will tell you about two use cases, fire risk management and plastic waste detection at the sea. So from satellite data, we can detect burnt area and fire fronts. We have added other information such as the determination of land use in order to identify urban and rural areas, to detect houses at risk, such as isolated houses in the middle of the forest, to identify the roads and to detect the elevation of the ground. So with all this information, we were able to establish a map which identified areas there that may be difficult to access for rescue teams. For forests along the road, remote houses. So this map is even updated with changing weather conditions. As a risk of a wildfire increases because of climate change, this use case can really make the difference for rescue operation and wildfire prevention in order to survey the right area, depend on the weather condition, and to organize their rescue around in order to survey our area. So the second use case that I want to present you is a subject in collaboration with the University of Edinburgh in Germany, financed by the European Space Agency. So here we are in a downstream study, and the first results are very promising. The long-term objective is to be able to detect and track plastic waste in the ocean. This marine pollution is dramatic for our environment. The biggest contributor to this pollution is disposal plastic floating in the oceans. So many initiatives of waste recovery are being created. So because many of our industries pollute the oceans indiscriminately and do not assume the cost of the action. So we must act. So as you probably know, oceans are big, and say that the task to find this plastic is big in an understatement. That's why we propose a complementary brick to the cleaning initiative, that is the detection of all this waste via satellite data. So our data scientists use data from Copernicus satellites to detect plastic litter patches. And with deep learning algorithms were also used to simulate the shape and movement of plastic waste in the ocean and train algorithms to efficiently detect plastic waste. So we can detect 80% of plastic in ocean. So tomorrow we want to scale up in order to have climate and environment ministry and NGOs to send people boats to clean it. So with these two cases that I present to you today, you can see that we can do by combining AI and satellite data. And so with this combination, we can be really open-minded of all the possibilities that we can do. So this combination can provide us with decision support indicators, thus allowing us to change our impact on our environment for the better. So thank you for your attention. I'm there also if you have any questions.
Thanks, Sandrine. That was fantastic. I think we'll open it up with our Q&A stuff. So again, if anyone has any questions, please feel free to use the Q&A chat box. And I see we've already got several questions going. So I'll open this up for the panel. Our first question comes from Daniel Saznino. Hopefully I said that correctly. If I mispronounced your name, I apologize. But he's got a question. What's the plan for energy, oil, and gas companies for the future in terms of sources of income? For example, instead of selling diesel and petrol to end customers, would they sell electricity from chargers, or maybe they'll sell digital products related to emerging technologies? So I guess the question is how is all this going to transform the industry?
And I'm guessing, Neil, that's to me.
It's to all of you. So whatever you would like to chime in, but Dan, if you want to kick it off.
Yeah, let me kick it off. So I think, I mean, I started out talking about energy transition, and I think that's a really good term because, you know, there's a lot of sectors which are very hard to abate, and I think all of us here know that. You know, cement, steel, you know, heavy industry are all, even things like marine, aviation at the moment are all looking for solutions. And I think, you know, our role is to try to accelerate the transition as quickly as we can by working with our customers to give them what they need. And there's some fantastic examples of things that we're already doing with that. And if people haven't seen that, you know, some of the work we're doing with Rolls-Royce or Penske, which we announced as part of our recent strategy day, you know, with videos that are on our website that people can check out. Some of that work is really transformational. Similarly, also the work we're doing with KLM to develop synthetic kerosene, you know, basically taking CO2 from the air and turning it into aviation fuel. Some of those areas are really powerful examples of you know, potential transformative technologies that are going to accelerate transition. But I think, you know, as I said, oil and gas will be with us for some time to come. We need to make that as effective and efficient as we possibly can, and also help our customers transition as quick as we can. And hopefully, and we believe that in that are new business models that will emerge from that, because the world is still going to need more energy in the coming years.
Great. John or Sandrine, anything else you'd like to add for this question?
Yeah, I think it's truly important to collaborate with across all sectors on this. Really, there's what we find quite often is you know, even within our company, we can you know, bring in people from many different sectors and you actually get that kind of learning across the board. The transition is going to be fairly difficult. You know, if it was easy, we probably would have already done it. And it really takes technology development in from completely end to end, from energy source through to the user.
Yeah, totally agree. We have to help also the transformation. It's working together. It's not only let's say one guy who work alone. It's big transformation and in different way, and it's a big point to be really work as a team and to make a good transformation.
Great. Sandrine, I see you're actually responding to one of the questions, but I think there's two questions that tie together here about you're talking about the plastics. So what one person was asking about, you know, because plastics move the ocean flow, how accurate is the application in tracking them? And there's a kind of a complementary question to that about another person asking, can you apply the plastic detection technology on land as well? So we'd love to get your thoughts on this.
Today, as I said, that we are in a downstream study. So it's the first time that we are working on it for the satellite data, and we are working on simulation. And today we succeed to simulate the satellite data with this and with the signature of the plastic. So we really believe that we can detect this plastic, but it depends on the site today. But we identify a specific signature of this plastic, and to say how accurate is this application, difficult for me to give an answer because it's still on downstream study, and it will depend on the size of this plastic. Really small particles. Today, I'm not totally sure that it will be possible, but often the plastic floating make aggregation together, and that's why we say that we have a new plastic continent over our ocean. So I think this big plastic area, I'm sure that we can try to identify. So today it's a downstream because our satellites are not today really observing this the ocean with the high resolution. So today we are proving that it can work in order that the agency can focus the satellite on this area in order to work on it. And to work over the land, we are not looking on it today, but we succeed to simulate this plastic, and it's a really good idea to observe the land use. Yes.
Sandrine, I have a quick question for you, actually, if that's okay. So obviously, in our work in producing electric vehicles, one of our objectives is to reduce air pollution in cities. And I noticed that your presentation there mentioned using satellite imagery to monitor air pollutants. Do you ever validate the satellite data with on the ground data as well? Because it's can be a very local, like different air pollution, two sides of the same street, right?
Yeah, we are working on this air quality, and we because there are some specific satellites or provide some atmospheric particle information, and we but for sure the sensor on the ground are more accurate, of course, because we are in not in the same level, but we succeed to mixing all this information on the ground and from satellite to have a better sample on our cities. But we can also we are working also for the rural area, because in this place there are not sensors as in the big cities. So we are really working on this topic, yes, and it's possible.
Amazing, good to hear.
Great stuff. Got a good question here, because it's something I see every organization struggle with when they start off with AI. So when talking about AI and its implementation in your company, how ready were you for AI? And did you have to outsource any of the work? So basically, did you have to try and build up the capability? Were you able to adapt, or did you have to find partners? So I'll open up to the entire panel.
I think I have a fairly short answer for that. In our company, we didn't really have much of a precedent. You know, as a startup, we didn't need to recreate systems. We were simply creating systems. So actually, this concept of building things to the technology that we know to be available now has worked quite well in that regard. You know, we're quite set up for it from the get-go. And the kind of important thing from, you know, now onwards, not just for us, but for everybody, is to kind of keep up, is to build systems that are flexible and able to, you know, scale and use the emerging technologies as they emerge.
Well, fantastic. I love that you focused on innovation rather than just automation, especially with AI. So a lot of value gets tapped out of. So Dan, Sabrina, anything you'd like to add?
I'll jump in and say we're obviously the other end of the spectrum. So unlike John, I had a lot of legacy challenges in trying to adopt this. I mean, we started this journey, I guess, 8 years ago back now. And so it's been a long journey. We didn't call it AI back then. We talked about advanced analytics, but really it's been an evolution. I think the main thing is for us, we've focused on two things. One, we knew we had to build our own internal capabilities. So I talked about, you know, building out a data science team. We were lucky in that we had a lot of people in our organization who had the right raw materials to be data scientists, but we partnered up with companies like Udacity to help with reskilling, as well as also bringing in some talent from outside. So that was very much the way we went about building the core team. But actually, more importantly, we built a network. So one of the big learnings I've had is the importance of community, because that's how you get to the front line. And so what we've been doing is building a network, which is about now 5,000 people, which is called the Shell.ai network. And basically, we have regular webcasts and content and annual reports and conferences and a very active social media channel internally, which talks about all the things we're trying to do across the organization, and brings that community together. And I think the final thing is we've thought about it as a change program. Our ambition is to try and embed AI into every part of Shell's business, because we believe that's key to Shell's mission. And so it's very much been that, and it's been top-down supported as well, which is another element of this. But it's definitely been a change journey, and it's definitely not easy.
Oh, thanks for sharing, Dan. That's definitely very different than John's experience. But that's good, I think, for all our audience to see the different perspectives. Sandrine, anything you'd like to add?
Yeah, it's for our company, we are not a startup, so we work since a long time with different technologies, and we are working also on AI, and we made a lot of proof of concept and so on. And today, and some more years ago, we are really working on scale up the AI, and also I'm working with satellite data, and these data are really heavy. It's we need to have a very big infrastructure. We work especially with cloud and so on, but we also work on framework who can be more intelligent in order to really launch the right algorithm and on the right time in order to really improve this. And also it's working with algorithm, how we can work with the technology and to be sustainable and green as we can.
Awesome. Well, I think 3 good perspectives, because I know it's a common thing that a lot of organizations struggle with, but I think you got some good stories to pull from on what you can do for your own organization. This question is specifically for you, John. So it's, what is Arrival's views on battery manufacturing and EOL solutions?
Well, our view is that we need to apply the kind of circularity principles 100%. You know, if we look at kind of holistically at the environmental impact of a vehicle throughout its whole life, there are kind of, you can divide it up into main sections. So we're talking about the manufacturing of the vehicle, of which a section of that is the battery, obviously. The use of the vehicle, the then maintenance and servicing, all the way through to the end of life disassembly and dismantling, right? So in the transition to electric vehicles, we're tackling that use phase primarily, right? So switching to electric as a kind of powertrain, you can bring that use phase right down to very close to zero, if not zero. if you're charging it with renewable energy, great. So that's that chunk dealt with effectively. The next biggest part is then the manufacturing phase. So what do you do there? You can work towards efficiencies. You can bring down the energy usage. You can even switch to renewable energy again in the supply chain and in your own manufacturing. But that doesn't achieve everything. There are still raw materials being extracted. So in closing the loop from end-of-life vehicles back into being your new raw materials, you're able to bring that section down much, much further. So really the kind of priorities in tackling this big picture is, yeah, okay, we start with the use phase. That's the kind of low-hanging fruit. And then the sort of medium-term thing is to really go after closing the loop. So when batteries are damaged during life, they need to be recycled. But if batteries are, get to the end of a vehicle's life and they're still useful, like I was talking about earlier, where you sort of view the vehicle as a whole of a collection of different systems, each with their own life and their own kind of utility, then if you can reuse that battery, great. And we've designed our own vehicles in a very modular way, so they're easy to disassemble and to actually repurpose. But also that recycling step is an incredibly important part. So there are companies setting up all over the world now for recycling of lithium-ion batteries, and many of those are producing battery-grade minerals that can go back into the process. So we completely intend to utilize all of those principles to actually tackle the overall environmental impact in quite a holistic way.
Great. I love the perspective, or really the attitude, I should say, about recycle and repurposing, because we can actually take waste and sometimes turn that into resources. We don't usually think about that, but the way our planet is heading and the way we're going to help people is to have that mindset. So thanks for sharing, John. Dan, this question is specifically for you. So we've got a question here that says, what is Shell's plan for sustainable energy? That's, pretty broad, but maybe you can add little highlights to that for us.
Yeah, I mean, I'm not sure I'm qualified to talk on the whole aspect of that. Obviously, AI is my specialism, but look, I mean, let me just say, I think actually today there's a new sustainability report that we've put out. I think also there's a Powering Progress website which Shell's put out there around some of the ways in which we want to transition. There's obviously scenarios in this. We're well known for our scenario planning, as you will know. And so we've tried to model different scenarios forward as the world evolves. And so much of this depends on a collaboration between customers, between governments, and obviously ourselves playing a key role as well. So I guess that'd be what I'd say, but I'd refer you to those materials, which will do a better job than I will in detailing that out.
Great, thanks, John. And if you have any links, feel free to share them in the chat room for people. Another question that I think is very interesting: where do you see future opportunities in green jobs coming from, and what are the skills needed that would be in demand? So I open this entire panel. What are your thoughts around the green jobs?
I can kick that one off if you like. So
sure.
I think that I guess from our experience, we want to bring up effectively the kind of carbon literacy, for want of a better name. So we want people to understand environmental impact much more in a much more widespread way, right? Everyone through to people outside of the industries that we work in and outside of the kind of technical fields. And so what would be really great from our perspective is actually a kind of generalist view of some of these technologies of AI and other kind of digital technologies that really also tackles the environmental challenges that we're up against here. So how building things into actually education institutions to bring two skills in one and broaden the kind of knowledge base there. If we can apply some of these technologies for modeling environmental impact and things like that, I think that will become a lot more widespread.
Great. Sandrine or Dan, anything you'd like to add around green job opportunities?
the green job that I'm see from my part, it's as I said, how to improve the infrastructure, the architecture that we can imagine in order to really work with these AI models and with big data. As I said, as observation is really big data to manipulate. And for instance, we are working for reinforcement learning, which is really interesting tool to work on this, but it's not still really mature for this architecture. And I think this point it can be really interesting to look on it.
Great. Dan, any thoughts you'd like to add?
Yeah, I mean, maybe just adding a different perspective. I mean, you know, what's really interesting for me when you think about you know, green jobs in the employment market is the fact that almost every job is becoming a green job in one way, shape, or form. I mean, my LinkedIn feed these days is filled with companies making net zero pledges by somewhere between 2030 and 2050, depending on the organization. Which I think is wonderful. I think what's really interesting is also that when you talk to these companies, many of them don't have a great deal of a plan of exactly how they're going to get there, because it's just really hard. And so I think what's great is actually that I think, you know, for all of us, no matter where we're working, this is going to be the challenge of our generation, I think. What I'm excited about is the fact that I see a maturing of the conversation. You know, and I think the fact that we can get together an oil and gas company or a traditional oil and gas company becoming an energy company, you know, a startup and a consultancy all talking with different perspectives on this topic is just a great example of what it's going to take to make this work.
Awesome. I love the attitude, Dan. I'm going to modify Alex's questions a little bit because I think it's touched on something important. And I'll use actually an example that Sandrine shared with like the wildfires, where we often think about AI as like automation. So if you remember, how did we used to spot wildfires? We literally had people looking through binoculars at areas to see if we could see signs of smoke or fire. And now we're using visual recognition and satellite imagery and all that kind of stuff. Is that kind of the techniques and the focus for AI, or are there opportunities to leverage this technology to do something better? Like, could we predict wildfires and not wait for them to happen? Or can we predict things around energy usage or waste or all these things? So Sandrine, I see you're already anxious to jump in. Love to get your perspective.
Yeah, but the application that we propose is really to propose a map of prevention. It's where are the risks, where are the wildfiremen should take a look at the state and to observe really how they can planify their round to be sure that this part is more critical because we take account in the weather condition. Today, the wildfireman has a map, but not dynamic. It's just okay. This it's the land occupation, so it's the area in this place and so on, but not take account of the weather condition. And of course, another point is the human being with the smoke, cigarettes, and this. It's difficult to prevent, but close to the road, it's also a risk area. So we can also detect this kind of risk map and with this difficulty of human being, but it's another point. But yes, I believe in
Great thoughts. I chuckle to myself because my mom always asks, like, you keep working on artificial intelligence. Why don't you work on real intelligence? You think about all the people challenges involved. But Dan, John, any other thoughts you'd like to add?
Well, I mean, I'm just hugely excited by the potential of geospatial in general. I mean, Sandrine's touched on some fantastic applications. I think there are many more actually. And I think methane is one area that we've looked at a lot of how can we leverage satellite data. In fact, we entered a hackathon recently with Microsoft, which we won to sort of look at how we can start to use some of the data that Sandrine's talking about to accelerate our understanding of where methane emissions are coming from. And that's going to be a key one, I think, for our industry, but also more broadly. I think the other thing that's going to be interesting is what I'm referring to as multi-scale geospatial, or as one of my early data science teachers would have said, multiple lines of evidence, and I think John touched on this. I think the exciting point is going to be geospatially located combinations of sensors, drones, aeroplanes in conjunction with satellite imagery powered by machine learning to stitch those things together to provide insight. And I think it's that sort of thing that's going to be critical to cracking some of these big problems. I think the other thing is going to be the search for materials. One example of that being biomass. One of the areas that we know we're going to have to be able to get after is how can we find more sources of appropriate biomass to generate biofuels, as an example. And I think that, again, my view is AI can play a role there in helping to identify new sources of materials. So I think there's the possibilities are endless in this space, and I think we're only scratching the surface of the potential here.
I would add a bit of a general point about automation, really. So you can use automation to simply automate and speed up or improve the repeatability of something that would otherwise be done by a human, right? And that's great. You can speed up data processing. You can do many more things per minute, per hour, per second, whatever. But really, the leaps forward in this type of technology occur when you're creating a new way of working that isn't just the human way, but sped up. Don't just give a robot a screwdriver, give it something completely different, that would revolutionize it, and something that actually works to the strengths of whatever type of automation you're talking about here. So, maybe a challenge to everyone there is to think like a machine, not like a human.
All right, think like a machine. Interesting advice. I kind of like it. But I think that's probably a good way to wrap up our session. Again, if people have questions, I encourage our panelists to take a look at the Q&A chat box and see if you want to respond to any questions we didn't have time for. But we do have the second half of our session all teed up. I'd like to hand it over to Barbara to get that rolling.
Thank you very much, Neil. I'm just waiting to be online. I hope that works. Can anybody give me a thumbs up, please?
We can hear you, Barbara.
Okay, perfectly well. Well, thank you. So thank you, everybody, and welcome to the second session, AI in Smart Cities. But I also want to thank Bilal, Paolo, and Neil for running the show today and for organizing everything. And I remind you of joining our webinars tomorrow in the afternoon. And Charlene will send out the invitation and the registration later via the chat. And also let me remind you that you may send questions via our chat today to our speakers. But without further ado, I would simply like to introduce our first speaker, Kari Eich. Kari is the Secretary General at the Organization of International Economic Relations and FGAI AEE Vice Chairman. She has been working on smart cities ever since I think I know her, and all of us have known her. She is currently based in Norway to work on a very interesting smart city project, and she will jump on that directly. So our focus at this session will be mostly with SDG 11. And Kari, may I hand over to you right now? You don't need any further introduction. The floor is yours.
Thank you very much, Barbara, and hello, everybody. Very nice to be here. I'm going to share my screen just a second here, if everything works well. Yeah, do you see it now? Maybe Barbara or anyone could just give me a little thumbs up. Yeah, works perfect. Okay, ska vi se. Yeah, I'm going to talk about digital twins and AI in cities. And I have set a very, would say, holistic approach to this, and a very, as was said here in the first talks, about how do we actually get collaboration to have more holistic view on how we develop smart and sustainable city. I'm just going to, in the context, very briefly, I'm just going to mention that we have a project called United for Smart Sustainable City that many of you, I know, online here are related to. And we are looking into how we can actually not just get all these fantastic solutions into city, but how can we also actually measure and know where do we stand before we start to apply a lot of these technologies.
Kari, one interruption, sorry, I hear that your screen is not visible, at least for people from outside. I can see your screen very well, but I don't know if our viewers can see that. Can you take care of that, please, Charlene, or the technical?
You want me to share again, or like?
No, everybody see it? No, it's working now.
It's working now?
Okay.
Perfect.
Yes,
okay.
Thank you.
Fine. Yeah. Okay. So yeah, so this, just very briefly, this is a coordination, I would say, approach by 17 UN agencies supporting smart and sustainable city development around the world. And this is a little bit the basis of how I'm getting into the digital twins and how we're working on that. We have something called the U4CC Key Performance Indicators, which is indicators that have been developed for smart sustainable cities. And they are, just let me show you here, these indicators have been set up to support cities, not just in terms of giving them an overview where they stand currently in all these different dimensions, economy, environment, and society and culture, but also giving them something to compare, be able to compare and cooperate and see where do we stand, but where are we actually going to go. And this has been developed over, I think in 2016, we launched this. So this has been going on for more than 4 and 5 years now. This is a scoring. So it's this is a traffic light scoring of the biggest challenges, I would say. As you can see here, the green is the highest scores on all these different elements. And then you're going into the yellow and the red, which is the biggest challenges that these through this evaluation that we are looking at. And of course, this is massive data. As you can see, you cannot even see it here because it's so much into one here, but it's so much data that needs to be looked into. And how do we really understand the not just the challenges, but also the effects and the possibilities in all of that? And that's when the digital twins come in. We are so lucky now that we're working in Norway with a very big group of cities. So there's more than 45, or I think actually now 50 cities that's been evaluated using this method. And when we started to look into how to get these cities to cooperate and how we can look into the common challenges, because there's a lot of common challenges through these cities, we needed a tool to look into how we can really understand this data. And in Norway, there's been a long tradition on working on offshore simulations and using digital twins for offshore. And actually, my colleague Joel Mills, who is also vice chair in the focus group, he's leading this work, not just also for the focus group, but also within the U4CC, to look into how we can use these digital twins for cities. And what we started to do then was to look into the key, I said the key elements. This is one of the cities in Norway. As you can see, this is the snapshot report from ITU will be issued. And then instead of just looking into, the main challenge, looking also into then the integrated approaches to these different challenges of these cities. And of course, as someone was saying to me, instead of reading a report that is 1,000 pages, you're looking into one picture. It takes 5 seconds, and you see immediately not just the challenge, but also now a lot of the different user cases. All these different cities are part of the program, have got their digital twin, and are working on very specific projects to not just mapping, but also looking into here how they can understand and start to model scenario the different opportunities, because that's what it is. It's not just, of course, a visual tool. This is something that is collecting data and really starting to model scenario a lot of these different effects. This is some other projects that you can see. This is also really core of the evaluation we do. The water systems was very bright red in most of the cities in Norway, but also building energy, mobility, as you can see here, public service. And there's a lot of interesting projects coming out of this one project and the testing that we are doing just now, having this really big hub of cities working together in the country. Yeah, also here some other cases that we're looking specifically into, of course, the sea level rise, these type of things, but also in terms of sustainable investment and how this can be model scenario, what is really needed, how can we get an understanding here. And we work a lot with the finance sector currently to see give this understanding of what is needed and what is absolutely not needed, what has the biggest effect on environment, society, and economy, and using those first, target those first, not everything, but those first, and finding these use cases that we can then really multiply and replicate in cities around the world, which is what we need to do and why we need these tools, because we need to be much quicker and much more effective in the way we are planning our cities and how we deal with all this data, which we have available, right? But it's not really used, much of this data. So now in this way, it can be integrated into this whole approach. This is also some other use cases. As you can see, we are also starting to take it outside of Norway. So there is a lot of also cities now outside, but also part of the program that is getting now the digital twins. So we start to get a lot of use cases. As you can see here, it's maybe a little bit small, but everything from how we put the bikes into play and a lot of these things that we are looking into in terms of the total evaluation that we're looking for. So this is also just from the simulator in Norway. There is one building where we have more than 45 simulators. And this is one of the big ones where you can actually fly over any city. And I was talking to Joel, and to make a digital twin of the city takes around 3 days. I mean, this is not just something that is coming in the next 10 years. We can do a digital twin very quickly and then start to put in this data that we are then, collecting, but also any type of data, right? You can layer anything here and start to really get a much more holistic approach to city development. So I think that was what I wanted to share, and I'm happy to get questions and look more into it afterwards. Thank you.
Well, thank you very much, Kari. And I think what is most important is that when you shared the KPIs, that it's not only the modeling, but it's also the outcome is best practices and learning from each other for the cities. I think this is very important to keep in mind. I would suggest that we continue with Ariel right now. And then at the end we collect the questions. Ariel Liebman is the director of the Monash Energy Institute in Australia and has been working on those issues for a very, very long time. And it's my pleasure to introduce you right now to Ariel. Please open your microphone. And Ariel doesn't have a presentation right now. He would have had one, but he decided not to use them. I'm sure that he will share anything with you if you send us notes in the chat or in the FN Q&A. Ariel, the floor is yours.
Thank you very much, Barbara. And I don't know how I could have had a presentation following on from Kari that could have had a hope of matching the visual impact. So I'm quite glad I didn't really have a presentation. I do have one motivating slide though that I decided to put in, and I'll just throw it up there and keep it there for a little while as I start. So this is something that sort of informs a lot of our work at the Monash Energy Institute and my personal passion as to why I do this, and that's the climate challenge. When I started working on this 15 years ago, seemed pretty bad, and now I'm a bit concerned. We're even more up against the wall, where we need to reduce our global emissions by not only 100% by 2050, but that's actually probably the easier task to my mind. I think the nearer term emission reductions are what sort of worry me, and so we really need to reduce global emissions by sorry, suddenly someone is messaging me in the middle of the night here in Australia, so I don't know why. This is really a great challenge. And so what we found is that AI, and we call it AI now, but when we started, we talked about various aspects of computer science, machine learning, and optimization. It can contribute to this. So in particular, as I was saying, with the trajectory that climate science tells us means we have to reduce our global emissions significantly by 2030 and beyond. This is a big challenge, but there is hope on the horizon with mass-scale renewable technologies becoming competitive with fossil fuel sources. This is happening even in places such as Australia, where coal and natural gas are one of the cheapest in the world in terms of production costs. And even in Australia, wind and solar are cheaper than coal and gas-fired electricity. When combined with other key technologies such as batteries, rooftop solar PV, and electric vehicles, we have a complete set of solution blocks for mass decarbonization of electricity, as well as transport through transport electrification. These two sectors account for up to 2/3 of the world's energy-based carbon emissions, according to International Energy Agency figures. And we can also increase our impact there by electrifying many industrial processes. So we can approach maybe 3/4 of the world's emissions by electrifying those and then switching to renewables. Parallel trend that should not be overlooked is they're directly related to proliferation of these large-scale technologies is the advent of, as I said, rooftop solar PV and other distributed energy resources. That includes also community and residential batteries, as well as electric vehicles, which are coming, which will hopefully soon be used in vehicle-to-grid functionality and become part of an ecosystem of technologies that can be used collectively and coordinated. While we do have many elements of these solutions, we really just have the elements when you talk about technologies, and integrating them together into the legacy infrastructure, our old grid and our coal and gas and oil-fired power station is a challenging task, because this grid was not designed to accommodate these new and digital technologies. So this is where AI methods in their full range of forms come in, particularly optimization, machine learning, and data science, time series forecasting, as well as anomaly detection, to name a few, have a crucial role to play in the design and operation of this future carbon-free electricity grid. Together, these trends work to create a new energy future, which has a strong chance, I believe, in meeting our 1.5-degree climate objective. One of our key research partners, International Energy Utility, NG, has been known to describe this as that the future is 3D, decarbonized, distributed, and digital. And today, we mean, by digital, we mean AI, at least for the purposes of today's sessions. So I'll just conclude this with a couple of examples of how we use specific technologies and AI technologies at Monash and around the world. So optimization is actually AI technologies is perhaps a little bit overlooked in the excitement around deep neural networks and things like that, but it's really a workhorse of digital intelligence, really, in my view. So at the Monash Energy Institute, we have a strong focus on the planning of the system of the future. And for this, optimization is key. There are many subfields of optimization, and many are useful in solving this problem. However, the foundation is, of course, linear programming and its extensions, mixed integer programming, as well as its associated methods of reducing the size of the problems, and decompositions such as Bender's decompositions, for those who have heard of it. So these can be used respectively for operational planning. How do you schedule generation and storage to balance your renewables, as well as the more difficult problem of planning the system of the future over a horizon of up to 30 years. In the past, these problems were decoupled. You could plan the system without worrying how it would operate, because you knew roughly what the mix of the different technologies was. But now these are coupled, and need to incorporate. We need to incorporate the short-term operational scheduling problem into the whole grid expansion problem and the investment problem, because we need to work out how to create a mix of technologies that balances supply and demand on a short time scale. That means we have in AI terms and optimization terms to formulate the whole 20 or 30-year problem as one giant mixed integer program, which is a very difficult problem to solve, and speeding it up is a very important challenge. And it's not something we've ever had to do before in planning our grids. So there are some existing tools that allow you to go some of the way there, and we've used some of these tools at Monash, for example, to demonstrate that the fast-growing grid in Indonesia can achieve 50% renewables by 2030 at no extra cost above a fully coal and gas build-out. And the same tools are also used by the Australian market operator to prepare their biannual integrated system plans. However, these tools do struggle with these problems and really are not fast enough to fully sweep the range of future scenarios, which are made even more difficult by the fact that there's a lot of uncertainty about the future costs of these technologies. We know they're going to get cheaper, but how much cheaper, and therefore what is the actual efficient mix? To this end, we've actually working with Data61 and CSIRO, a couple of Australian agencies, to develop methods that can find these efficient plans over these longer term horizons. And that's using various methods of reducing the problem and other clever tweaks. So this is really the bread and butter of modern optimization work as applied to these areas. Another area that is worth mentioning is something a little bit different, and is how we use reinforcement learning and machine learning to manage distributed energy resources. Now, the massive uptake of rooftop solar and the emergence of batteries and smart grids are leading to the opportunity to collectively flex the community's energy resources, and through schemes such as virtual power plants and transactive energy management concepts. These are beneficial because if you can flex collectively your demand side, you can integrate a lot more renewables, variable renewables, which are not controllable, without having to invest in what is so far relatively costly storage. So we have actually turned part of our campus into a living laboratory at Monash in Melbourne, where we are creating a flexible microgrid-like precinct. And this is part of our COP24 UN award-winning net zero initiative, and we are well underway in that, by the way, to reduce our climate impact to zero by 2030, and we expect to be there even well before that. So in order to flex these buildings collectively, we need to actually learn how the buildings respond to changes in their set points, because they're not really designed themselves to be very flexible. So we have to actually reverse engineer their behavior so we can control their demand in a way that doesn't impact comfort, i.e. temperature or humidity inside too much. And so it turns out that a really good tool for this is reinforcement learning combined with neural networks. And we can actually learn and build a predictor for how to guide the building towards different ramp up and ramp down behaviors. So I think I'm getting pretty close to time. How am I going for time, Barbara?
You're doing fine. You have another 2 minutes.
Oh, great. So I'll talk about another application then. So then we go to sort of maybe more classic AI, or classic in the modern sense that most of the community thinks of AI. That's how do we apply machine learning to some other problems in this field? So, and so until we get close to a fully renewable grid, we will still need to coordinate the operation of fossil generators, such as coal and gas-fired power station, together with the demand side and uncontrollable wind and solar. And we'll also have another tool in our toolkit being batteries or pumped hydroelectric storage or existing hydro. Now, for scheduling purposes, we need some very good forecasts of the quantities that cannot be controlled. And in the past, we had to forecast demand, which is the aggregate consumption at various points in the grid. But now we not only need to forecast that, but we also need to forecast wind and solar output as being the two primary renewable technologies that we will be seeing in the grid. Perhaps they'll dominate 90% of the electricity production in the next 30 years. And so these are getting tricky. They are tricky to forecast. They are different in their characteristics to demand, and therefore require different and improved machine learning and forecasting methods. In particular, you can see that for forecasting wind, there are other bits of information you can use, like weather forecasts and wind forecasts. And for solar, you also start seeing key effects like the movement of clouds. And as they run over a large-scale solar field or over a city, these can significantly impact the production. So new methods are required here. And we have recently, in fact, completed a project with within one of our units called the Monash Grid Innovation Hub, with an industry partner to survey new forecasting methodology for solar and wind farms for use in the energy market operators' scheduling operations. So yeah, look, I'll stop there. I think that gives us a very good, hopefully a good overview of how we can use various AI technologies to help integrate these new tools, toolbox elements that we have, wind, solar, and batteries, into the grid. So I'll leave it there. And thank you very much for the opportunity to ITU to present on this.
Thank you very much, Ariel, for this comprehensive intro. There were actually two specific questions focused to you, one by Ken and the other one by Alex, that you can see on the chat. You might want to answer right away, and another one for Kari by Alain Kambaya with regards to the U4SCC and Africa. So maybe Kari, you also want to look into that and ask it. It's now my pleasure to introduce to you Albert Seubers. Albert is the Director General of Strategy of Smart X and Scientific Community member, as well as the Director of Smart Cities for ATAS. He has been with ATAS for a very long time, has always been in the IT consultancy after graduating from the Agricultural University in Wageningen, and in building technologies and biomass gasification. So he has a different background than the others have, but he will also focus on actually putting smart cities into practice, and also, of course, with artificial intelligence. So his emphasis on the city and to the direct link to the challenges on mobility and energy. Albert, the floor is yours. Please get started.
Thank you, Barbara. I will kick this off, starting sharing my screen. So when we talk about cities, and basically every presenter today talked about the value of the data that we need, that we can capture. Sometimes we have it and not even know the value of it. So instead of smart cities, in our company, we talk more about the data-driven city. What is the data we capture? What does the data tell us? And how can we put it in perspective of our daily lives? Important here is that my slideshow seems to be stuck. Okay, it's working. But just 2 words on Atos. Atos is a global IT player, and we take decarbonization really at heart. The meaning that we, as a first company, we sign decarbonization level agreements with our customers. It was mentioned earlier that companies have a strategy on decarbonization, but do not have a clue where to start. As an IT company, we know IT is one of the larger consumers of energy companies are using. So we're building that journey, a net zero journey with our customers, and we created a partner ecosystem to work with us. On the hard side of that, we know that AI, deploying AI, machine learning, costs a lot of compute power. So we have our own green HPC server lines that are manufactured and designed to operate with a reduced energy consumption good, because that's what we are. Companies, and you as people might know Atos from the Olympic Games, and the largest employment we've started in the 20 years that we're now working with the IOC, the Olympic Committee, is to operate the IT infrastructure for the Olympic Games. That needs to be secured, because everything needs to be safe, controlled, and managed, and you can't have an athlete ask an athlete when he finished his match to do it again because the clock or whatever technology was not working. So we see, and this is last year's figure or 2019 figures, because in 2020 Tokyo did not take place. We had to fend off 570 million IT security events. You can't do that manually. You need to create data analytics models to understand what is impacting, what is the source, and how to fix it. With zero impact on the games, and with a very limited number of incidents we have to treat manually. Looking at cities, all that comes into play because we, the entire audience here, we are citizens. We are causing the problems, so we have to fix the problems. How can we do this? Is by getting better information, be better informed about the impact of what we do. So basically in a community, we can capture data. We do capture data from the Copernicus satellite system, we call that Mundi. We combine that with local captured data on the environment, see the environmental impact, but it doesn't mean anything to me as a human if I'm not informed about my personal contribution, my choices, so if I get better information on what the impact of my choices are, I can help make that transmodal shift. I can help do the energy transition in a way that even at a small scale of one citizen or a smaller scale, larger scale of a community, even at a city level, we need to do it like that. That means we are going to use a lot of data, we capture it, we deploy analytics on it, but we have to build a trusted environment, not just trusted in the sense that we have to rely on the technology, that's a way of trust, but you and me have to trust on the information that's shared with us. So the AI that we deployed in various motions, we can say this is trusted AI, it's fair AI, at least it has to be transparent so we can understand what it means. Because talking about reduction and getting more resilience or sustainable, we need to provide healthy living conditions, air quality, sound, the digital twin, very good model, Karen, very, very interesting to see that, but how you can already simulate the impact of changes. Sound is killing number factor 2 in cities where air quality is number 1, but if we build a new high rise and we're reflecting sounds, all of a sudden the livability goes down where we were expecting it to go up with new modeling of city infrastructures. This is a big slide, but I will go use a few words on that. So the trust comes from the left. We need to build a network of sensitive data sources that we can trust. So yes, we need to secure the networks. We need to deploy cybersecurity. Edge is very important. Atos, we call that the post-cloud era we're in already. We don't want to feed all the data into a huge core system that we can do the number crunching on it. We need data to build the models, test the models, but we execute it in the edge. And with edge, we mean the whole setup of core, local, but for all, the far edge. If we can handle the data and keep the data there, we will lower the pressure on the networks and the network consumptions. We will lower the power on the HPC systems to make sure that we do this in a very much sustainable way. But it also means we have to build a data management function or responsibility at city level that really understands what it means to deploy a data analytics and manage data. On the right-hand side is where we are we're using the data and feeding it. Let us feed with the data so we can make the better choices and see what we can do here. So from a data management perspective, and you can forget about the picture, it's our reference architecture for smart city platforms based on Fireware, open source. So we, from bottom up, we work with what we call explainable AI or fair AI to implement in smart city solutions so we can put that trust on the information that we get. We build a privacy by design aspect because let's not forget, if we are more connected in the city, we are constantly at risk that our privacy is really, really intruded. And I know there's some people from the city of Eindhoven in here. Hi, Kejan. One of the projects we started already 8 years ago, where we started using data we captured on the street, analyze it in the edge to ensure that nothing of the data was shared with people that should not have access to it. We didn't even record the data. We only recorded the outcome of the deployed analytics to make sure that we feed it into the proper authorities. In this case, it was the police. So they were alerted on what possibly was going on, so they could have their own vision on it, being more educated and going on site. It was a reduction of cost. It was an improvement of livability in the economy. Local economy in the entertainment area went up because more people felt at ease in the area because they knew there was something watching them without watching them. So that's the great idea of privacy by design. So secure and trusted, and yes, open standards, open economy systems, so open ecosystems of partners. But here is where we work with cities. And as a member of the Open Agile Smart Cities, it's very important to implement what we call minimal interoperability mechanisms. So we work with the hyperscalers. We are very much involved in Gaia X as the next phase for European trusted cloud. Implementing minimal interoperability mechanisms means that from design, we have the private data security, we have the explainable AI, so you know what's going on, because in the end, it's all about transparency and putting trust in what we do. Urban data management, that's the term we use for this, is connecting the dots. It's on the wheel that I showed on the first slide. It's about basically everything. It's from public safety to transport, and we call it sustainability in all the levels that we work with. So yes, we work with cities like Grenoble, where we connect all the smart metering from all the utilities, water, energy consumption. We connect the local generated energy from the solar panels on the rooftops. We see the impact of grants provided by the municipality on the energy balance sheet, I would say. So basically, that's what it is. We create a balance sheet for a city based on consumption, lowering the consumption based on education of the citizens, feeding the balance with local generated energy or reuse of utilities, water. Too much water is still fed into the sewering system for a cleaning. So we try to merely clean rainwater in the sewering system. Why not use gray water systems to reduce the consumption of potable water? Because that's one of the most expensive goods that we have, and it takes a lot of energy to create it and pump it. So that local balance within a city, we can help manage that local balance based on the data we have and the information we can share with our citizens. The same applies for traffic and mobility. We see traffic strategies, but from an urban strategy perspective, if you understand the impact of changes in cities or the local situation on air quality, and you try to impact that with traffic measurements, you need to understand the outcome. So it's basically outcome driven. You know what you want to have, and the AI model will help you understand with this external conditions in this location, this will impact directly the sound reduction, air quality improvement, or at least you will not exceed the limits that you've set for yourself. But it also comes with the change in demands, because if you do this, you need to provide another mobility service or a solution. So yes, it's connecting the mass solutions that are implemented in cities, but it's all based on the change in demand and the way we operate. As a sidestep here, I was traveling the world. I'm in a global position. And last year, I spent 92% less of my time traveling. And my results were good. So we don't necessarily need to travel that much, but we need to adjust ourselves based on the information we have, based on the technology we can use to make ourselves go through the change. And this is deploying for more than just me. I'm an information worker, so I can do this. I'm not baking cookies in a factory. I know how that's different. But we do support engineers that usually would travel to a factory. Now they can repeat or restore situations online, remote, more and more often, even with digital twins. So in the environment, here is where I mentioned already the Copernicus project, the Mundi data, what we can combine at local scale so we understand the local impact of that. But very important here on sustainability is the impact on persons and how we live and how we act. So it's not just informing and a lot of commercial activities on change your diet, do this. because that's good. We know we have to change our diet sometimes, but we're not up to it yet. Maybe if we have this inspiration, so from people we can see as a role model, help understand what it is and measure the impact on our daily lives so we have positive feedback in a sovereign way. So if you use Fitbit, fine, you trust Fitbit with the data. But if you want to do it on a smaller scale with your own data in your own, let's say, trusted environment, it will inspire you to do things differently. So this is from a data perspective at city level. These are just a few topics, but you can imagine it goes beyond all this. Working on all these different topics and all the technology we need for it, we get recognition from a lot of companies and analysts, but we're proud that last year IDC, after 10 years of hard working on the strategy, 10 years in this position, we were recognized as leader in our smart cities by IDC. We're proud of that. We're proud of that. But if we go forward, yes, AI and fair AI. AI needs standards. That was one of the questions, will standards solve it? No, it will not solve it, but we do need standards so we can explain and operate it in many different cities and exchange the AI routines between cities because they're transparent and explainable. So from a scientific community aspect, we do research on how to make this AI explainable. On the digital twin, one of the elements of a digital twin is not just presenting the data we have and make it more transparent, it's supporting simulation, what is the impact of a change, but it also allows us to what we call shared XR, shared experience, working with companies across the world on a location without being there, well, is making possible. But we can also get our citizens' involvement in this city planning tool because we can visualize what it means. To be honest, even politicians sometimes have real issues to digest all the figures put together by an engineering company that supports the design of a new city area. If we can put it in a digital twin, in a visualization layer on 3D without specific technology like HoloLenses, you have that shared experience and you can understand what it means. On the edge side, my dream is that in the next version of networks, could it be 5G? I don't know. Low power networks that embed edge will allow us to keep our personal data personal. We access the city as a system, and we use our personal profile on a personal device to get the information we need without sharing it. Because the system a city is, based on the data we collect and the AI we can run, should be able to answer me my question based on my personal profile. So that's really a privacy by design aspect. And the most important message here for me is whatever we can dream of with technology, as a citizens, we need to trust it. So we rely on it and change our patterns of behavior. Barbara, this is my contribution.
Thank you very much, Albert. This is almost spot on. I have a question by my colleague Pierre Major, who is also working on the AI working group at ITU. And this is for you, Albert. Maybe you want to either answer right away briefly or type it in. He asks, is edge computing more energy efficient than computing based on hyperscale? And just be short, and then I will hand over to Kari and also Ariel to turn on his video that we can see each other during the discussion.
Yes, two short answers. Edge is yes, it can be, it should be, and it will be more energy efficient because it's a smaller machine. Secondly, it's more important to handle the data locally and get more efficient answers from the data we capture. So there's two purposes for Edge.
Thank you. Kari, I would like to ask you to discuss the question regarding U4SCC Africa that was sent to us by Alain Kambaya. Please, what is your take on that? We also had some links online already, but I think you should answer that.
Yeah. Yes. We see now we're working in Norway, but we're working, of course, in many cities around the world that is using digital twins and is using this technology. I think that the real game changer will come when we use this, everywhere. And we need, of course, to use this on the African continent and in every developing countries and cities, right? So what we are planning to do now, because time is running and we need to get this, use these tools. As we heard the examples here today, there are solutions and a deep, deep understanding on every field that we're working in, right? But we need this holistic approach to bring it all together. So we're planning to set up simulation centers in every regions of the world. And for sure, there will be several also on the African continent to be able to have the opportunity to use these technologies really hands-on, right? Together with stakeholders in the cities in each region. So Africa, top on the list for that question. But as said, in many, we are working also with Innovation Norway now to set up a center in Singapore. So that's also very, very close. We're also working to set up a center in the US now for US cities. So this is moving very, very fast.
Thank you very much, Kari. Ariel, I have a question for you. What challenges do large amounts of rooftop solar pose that need AI? Could you briefly cover that, please?
Yeah, so thank you, Barbara. So rooftop solar is a great opportunity, but also creates some challenges around voltage. So the urban grids were not really designed in many places to have energy produced at the what is usually the point of consumption. So you get to levels of certain levels of penetration of rooftop solar, which will raise the voltage above the standards that the system was built for. And typically the rooftop solar will then start to turn itself off or curtail itself. So in fact, you end up having a lot of wastage at a certain point. So one of the uses, and this is still an emerging area, is coordinating the operation of the solar inverters, and even better, coordinating the operation of batteries throughout the grid, so that collectively they can reduce voltage fluctuations and utilize the energy and direct it to where it's best used, either within the local area or through the transformer and back out to the rest of the grid. So that requires distributed optimization technologies as well as better forecasting.
Thank you very much. I have a question for all three of you, and you partly answered that already in your presentations, but where will AI be implemented in smart cities from your perspective? Where will it be implemented first? Albert, Ariel, and then Kari, finally.
Well, where? It might be a bit of a strange answer here, Barbara. It will be implemented everywhere. It's already there. But where it will help us most is specifically on the cases that Joe was mentioning. We need to improve our infrastructure. If I talk about an energy balance, is one of the things in Grenoble we saw is the impact on the local grid. We need to manage and balance that, make sure that we can understand what it means. Even on water, if we be more simulative and predictive on what's going to happen, we can reduce a lot of that. And one topic, we didn't get to that, and I didn't mention it, but was mentioned in one of the previous. I think it was the contribution done by Shell. If we have on biomass, I graduated on biomass, but that was already 35 years ago, so it's a bit long. But if we can help predict the biomass that we generate by ourselves, so if we reduce the consumption, the plastics, the packaging, all that stuff, in the end, the mass we produce, our waste, will be much more biomass based. So if we can help create technology for local biomass generation, energy, it will help build a new neighborhood with around a biomass energy position. That might change our behavior because we see the impact. We feel on our energy bill that we contribute to lowering the energy. We need a lot of data analytic capabilities to do that and understand that, not just the technology to do it.
Thank you, Albert. Ariel, what is your take?
That's a very broad question. I'm glad Albert mentioned that it'll be implemented everywhere, so I don't have to say that. I guess when we talk about smart cities, I prefer to talk about sustainable cities. The smart cities could be very technocratic, and I think that the term itself has started to bifurcate a bit on the concept. So in sustainable cities, I guess from an energy perspective, I think similar to the use case that I talked about before, coordinating these distributed energy resources is going to be a very major use, and also electric vehicles and autonomous electric vehicles. I think there's going to be an explosion of that at some point. The autonomous, of course, take a bit longer, and but then once that happens, you're going to have a really interesting interaction between the energy production, consumption, and transport through the electricity grid, and the decisions around where to charge your electric vehicles, and then possibly even impact your routes, because your routes will need to be energy efficient, and the energy efficiency of those routes will be might be dynamically impacted by the rest of the energy usage patterns in the grid. So if you're going to have a really efficient combined transport and electricity system that's also subject to the vagaries of fluctuating wind and solar production, you're going to have some really complex algorithms and interactions. So that's about all I could add to that point.
Thank you very much, Albert. Kari.
Yeah, I just want to say what I really would like to see is that we are doing a needs assessment of our cities, right? That's what we're doing through also the evaluation. We need to do a needs assessment also on the what has the biggest effect, right? Where do we need to put our most effort in using these technologies, right? To really do this bridge between human and machines. So I think there is, as Albert said, of course, it can be applied everywhere, right? In any area, but let's start with those that has the biggest impact. And of course, mobility, energy, the buildings, these water, waste, these type of topics that is just so crucial to achieve the SDGs, right? But artificial intelligence will be the game changer also for achieving the SDGs, for sure. But we need to put it into right trajectory, right? And work together and bring all of these elements together, and all these fantastic things that is out there needs to be brought into a holistic approach. And that can only be done through the digital twins and how we see this in a concerted way.
Oh, thank you very much, Kari. And I think this is kind of the right closing remark for this panel, because we always must remind ourselves that there is no such thing as one size fits all. And what is true for, say, the African continent might not fit for the Americas or for Latin America or for Europe or Asia. So we have to be very careful. And I think this is why we set up those working groups, why we set up those programs, and why we cooperate and coordinate our research and work with, on the one hand, with academia and with practitioners. And without further ado, I would simply like to thank our panelists here, and hand over to Geneva again. But since Paolo mentioned we had the first meeting live in Vienna, I would just like to point out that there is Aspen, which is the working smart city close to Vienna, and maybe we all meet and unite in Vienna. It's just a short advertisement for us here. And I'm looking forward to seeing you all soon. And thank you for all the questions and explanations. Back to Geneva.
Thanks, Barbara, and thanks to all our panelists. Really, I think great information, some great guidance for all of us, a lot to think about. Before I make a few wrap-up comments and hopefully share a few opportunities with everyone, we do want to take a moment to actually just do a quick survey. So if you could just take like half a minute or so to fill that out, we'd appreciate it. We're not going to display the results or like that, but this is really to help us understand how good of a job we're doing and make sure we're giving the great content. So you should see a poll pop up. Just please take like half a minute to fill that out. All right, hopefully everyone has taken a chance to complete the poll. So just want to let everyone know that if you obviously like to participate more, you can actually learn more about the work that we're doing in our focus group for AI for environmental efficiency. We actually have a meeting tomorrow that's open. If you look at the chat, you should see a link in there. It is tomorrow, 2 p.m. to 5 p.m. Geneva time. And there is separate registration, but we'd welcome all of your attendance. Obviously, you can tell that we're working on some hopefully very interesting things, and there'll be some more opportunities through the UN agencies on how we can use AI and other emerging technologies to help solve some of our big environmental challenges. So with that, I would just want to thank everyone for your time, your engagement. Again, if you hope you'll join us tomorrow, and if you'd like to participate more or see what you can do to help, please do reach out to us. We'd love to hear your thoughts and see how we can collaborate together. And with that, I think I don't think there's any other closing comments or any goodbye. So I'll wish everyone a fantastic rest of your day, no matter where you are in the world. Thank you.
Thank you very much.
Selector, rewind selector, rewind selector. Rewind selector, rewind selector, rewind selector. Selector, rewind selector, rewind selector. Rewind selector, rewind selector, rewind selector. Selector, rewind selector, rewind selector. Rewind selector, rewind selector, rewind selector. Selector, rewind selector, rewind selector. Rewind selector, rewind selector, rewind selector. 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 Selector. Rewind selector. Rewind selector. Rewind selector. Rewind selector. Rewind selector.